Alright, so we're now in chapter 12. We're going to go over the rules for exponents. So here are the objectives, some concepts and vocabulary. We're going to simplify expressions with negative exponents, simplify expressions that contain exponent zero. We're going to use a graphing calculator to evaluate exponential expressions. We're going to use the product rule, and we're going to use the quotient rule. So here is just the description, physical description of what exponents are. So you have a big number, which we call the base, usually on the bottom, and then you have a little small number that's usually in the top. It's called the exponent. So I would make a note and jot those terms down. We can only apply these rules if the base stay the same. So if we have the same base, then one of the first rules, we do the product rule. So they're using A to denote the base. So they're using the same letter to note it's the same. If it is the same, the product rule says you add the exponent. So you see multiplication of some base in exponent times another base in exponent. You just add those exponents and the base stays the same. Okay? So they show you some examples, and we'll do some of our own in Hawk. So here's some examples that they give you. Now, sometimes you might have coefficients, numbers out front, and letters. When we're doing multiplication, you're going to still multiply just like normal. 2 and 3, you're going to get 6. The rule for exponents only apply for those who have exponents. So the y's, you would actually add those 2 and 9, and they kind of show you that here. So they show you the 2 and the 3 pulled out, multiplied, and the y squared and y to the 9th. They're adding those, and they end up with this answer. So it will be very easy to want to kind of add the numbers or try to figure out to do something with exponents. But with numbers, you do the same that we've been doing. If we see addition, we add the numbers. Multiplication, we multiply. Division, we divide. Subtraction, we subtract. But when we're dealing with exponents, we have this power rule that says when you multiply, you add the exponents. So be careful there. Alright, so now we're going to talk about the exponent zero. Normally, the larger the exponent, the number is getting bigger. Okay, so what happens when we raise something to a zero? We get 1. That's always the case. It doesn't matter what the number is. 2, 3, 10, it could be a fraction. Anything to the 0 power equals 1. So note that fact. Here it is right here. 0, sorry, I said anything. It has to be a non-zero number. Any non-zero number raised to the 0 power is 1. If you have something like this, 0 to the 0 power, this is undefined. Okay, so be careful of that. So any non-zero number raised to the 0 power is 1. 0 to the 0 is undefined. So here's some examples going through that. Quotient rule. So here's what it looks like spelled out. We have 5 to the 4th. So there's 4 5s here. And we have 5 to the 2nd. So we're just dividing. 5 divided by 5 is 1. That's 1. So you just basically end up with 1 on the bottom, and you have 2 5s here. So you get 5 squared. That's 25. The way you do that with the quotient rule is you take what's on the top, you subtract what's on the bottom. So you have a 5 to the 4th. You subtract the 2 exponents. So division with the same base says subtract the exponents. That gives you 5 squared, and 5 squared is 25. So this is how it looks when we spell it out. You can write this out if you want, but sometimes the numbers get too big, and it will be really tedious to write out, a bunch of the same letter or number over and over again. So if you just use subtraction, you'll get there a little bit quicker. So here's the quotient rule. Non-zero real numbers, same base, subtract the exponents. So here's some examples provided by Hawks. Here is one thing to note. when you have the same base and you subtract the same exponent, 2 minus 2, you get 0. This is how we get 1. And then you can also show that with division. If you wrote out 2 x's, you just divide. And when you divide, you don't get 0, you get 1. So it'll never end up being 0. Alright, some examples here. One thing they're noting here, they're talking about coefficients are divided, not subtracted. So 15 and 3, you would divide 15 divided by 3. You won't subtract. You only subtract exponents when you're doing division. So be careful not to mix. And that is a common mistake, that we started mixing things up. So be careful. Numbers divide, exponents, you subtract those. Okay, negative exponents. So here, if we had a smaller number on top, we would still subtract. So one way they're showing you is you wrote it all out and divide the 3/4, and you would have 2 of them on the bottom, and so you'd end up with 1/4 squared. If you were to subtract them, you would end up with 4 to the negative second power. The way you change a negative exponent positive is you move it in the opposite location of the fraction. So if there is no fraction, you're going to move it down to the bottom. If it was on the bottom, you're going to move it up to the top. So that's how you get rid of a negative, which you'll see better in practice. They just show you this one example as moving it down and putting a 1 on top. That's if there's no coefficient. If there was a coefficient out here, that coefficient would be here. So let's say this was a 10 and this was a to the negative n, then 10 would be on top and this number would go to the bottom. So you'll see some of that more in practice when we do a few. So here are a few more examples. You got 5 to the negative first, they just move it down. Okay, do they show any that start on the bottom? I don't know. They do. So we're going to be simplifying expressions to have only positive exponents. So a couple of different things you can do. You could just add them, which you would be subtracting because that's a negative. You can put that down on the bottom and then do subtraction that way. A couple of different ways you can do it. It doesn't matter. I'll show you a few of them when we start doing them in the next videos. And so here is just a summary of all the rules together. So exponent 1 just means that power. Anything to the 0 power except 0 is 1. When you multiply, same base, you add the exponents. When you divide, exponents, same base, you subtract. And negative exponents get either moved down or up to change their position in the fraction. So what you notice, we talked about if the bases are the same. What if they're different? If they're different, these rules do not apply. You can't use property of exponents. You have to do something else if the bases are different. And then here's some other problems you can try out. So with the calculator, TI-84, above the division sign there's a button that looks like this. This is indicated to mean exponent. So you can put some number, raise it to a power. This is how you do that in the calculator, which I'll show you in practice, and you will get solutions.